Now, let's get to work. And our first panel discussion is so important. So, connected forces, the integration of mobile connectivity into defense operations and strategies. And oh boy, how many things have escalated in this field since last year when we met and discussed these questions. So I'd like to ask first to the stage and take the chair number one from the left, board member, Latvian Transatlantic Organization, Žaneta Ozoliņa, who will be our moderator of the panel. Welcome to the stage. And then please welcome Vice President and member of the Management Board of Latvijas Mobilais Telefons, Ingmārs Pūķis. Luz Fernandez, Chief Digital Innovation and Technology at NATO Communications and Information Agency, NCIA. There's a slight change in the panel. Instead of Minister of Defense, we have Evija Sīpola, Head of Communication and Information System Department of National Armed Forces of Latvia. And Stephen Douglas, Head of Market Strategy at Spirent Communications. Stephen, welcome. And good luck to you, Madam Moderator.
Thank you very much, Valdis. Good morning, everybody who joined this session, which, as Valdis said, looks is going to be very interesting and very relevant. And thank you for inspiring speeches from our ministers, which laid a fantastic ground where we could start our takeoff debating security and defense issues. I think there is no need for long introduction because at the moment when we are already in the third year of reaching the third year of war in Ukraine and experiencing different ways of warfare starting from classical 19th century type of war and stepping into war of future, in the war of technologies. Such issues as mobile connectivity becomes a very decisive factor in winning the war and reaching peace and stability. Connectivity is not something which only delivers to economic stability and prosperity, but it is also a very important tool to reach peace, security, and stability for citizens. So we are going to discuss the defense sector, but it is not so much about defense, it's about security and peace for citizens. So therefore, a very wide range of topics. But to start with, I wanted to mention one quote which I recently read about the theme of future of wars, that innovative power of armed forces depend on inventions, ability to adapt, and ability to adopt. And today's panel members are exactly from those fields, from those who invent, who adopt, and who adapt. So therefore, I can't see the better setting of the panel debating integration of mobile connectivity in defense operations and also strategies. And I would like to start with the first question, which I would like to ask each of the panel members, because you are each representing different fields and areas. And I would like to start with you, Stephen. You are working exactly in a company which is inventing and adapting to some extent. What is the state of affairs of integrating mobile connectivity in defense operations? Please, floor is yours.
Yeah, well, first of all, thank you for having me here today. I look after strategy for a company which focuses on the testing and assurance within the communications sector. And we work across globally the defense industry. And I think what we've seen in the last 18 months has been, from a global perspective, two strategic changes in priorities. Triggered, one obviously by what's going on in Ukraine, but also I think from initial learnings of looking at how to utilize commercial communication technologies. So about 18 months ago, or before that, there's been a lot of focus on testing technologies like 5G, how it could be used within the defence organisations. And the outcomes of that 18 months ago were starting to demonstrate two critical things. One, there was a number of use cases which were highly applicable, but they were mostly for what I would call less critical types of functions, back-end functions, like on their bases, like for training, logistics, supply chains, all very valuable, and had one common denominator on it once it was tested. They didn't need any adoption of the 5G technology. They could take it as a dual-use technology. But the other learnings that we started to see globally coming out of the testing that was being done in the trials was that there was a number of other use cases which were more for the front end, so more for forward operating, engagement-based oriented use cases like command and control, like enhancements of ISR, that 5G, while it was applicable, wasn't at a state of readiness that could be adopted easily by the military. And it was lacking in areas to this, which it still is in many cases, around security, robustness, resilience, specific equipment requirements around it. And that's triggered a strategic sort of change we've seen from some of the leaders, whether it's the Defense Department in the US we work with or other sort of Western allies, where the focus now has started to move to how do we rapidly resolve that issue if we are going to use a dual-use technology. And you're seeing two sort of directions there. One's towards the standardization processes. I think one of the gaps that the defense industry has had in that first wave of 5G, most of the standardization didn't involve defense organizations having their input. And that means most of the input into 5G was designed, as most of the Gs have been to this stage, from a consumer or an enterprise perspective. What you're now seeing is that defense organizations are starting to think about how they get themselves involved in the next stages of 5G's development. Now, this is slightly challenging because engaging directly exposes also potentially what you're requiring, and these are global standards with actors and other nation states which maybe we don't want them to know. So that's looking at ways how the proxies can be used and third parties to actually influence some of the standardizations. The second thing we are also seeing is a focus on open source and open network technologies. One of the challenges, again, a number of the militaries we worked with had identified is to evolve these 5G systems for defense purposes. Getting the traditional large vendors to do it is quite a time-consuming process, and in many cases it's not commercially viable for them to do it. But having more open technologies which will allow you to rapidly adapt or change is something that's now being focused on. So we're starting to see a lot of the military organizations starting to push in this direction to explore open source technologies and open networks like Open RAN technology. And the third area I would highlight that we're starting to see as well is just also a focus, and I think this is a careful focus, but is towards tactical use cases rather than thinking purely strategic. And I think the Ukraine is the sort of catalyst for this. I think we saw a couple of immediate learnings. Number one, as a Western countries, we probably have lost our leadership in some forms of electromagnetic warfare over the past 10 years. We probably 10 years ago had over-superiority and got overly confident with that and haven't invested in innovation. And we saw in use cases in the Ukraine just recently, for example, where Russia has been able to jam or spoof short-range tactical missiles because the technology on board them is legacy that's been supplied to them. So that's starting to trigger a focus about how do we use more a mixture of, say, conventional capabilities we have today with 5G, not be scared to use them, but combine that with innovation immediately. So things like swarms of drones, which could combine electromagnetic warfare capabilities that may not be the most futuristic, but combined in a swarm, you can saturate potentially what Russia's trying to do. So it's these types of rapid tactical innovations we're starting to see and being tested and trialed at the moment. Now, I want to put that on one side because the only last comment I would make in this is that we should not over-rotate to just tactical. It is important, absolutely, for us right now. But there is other state actors out there who are not involved in this conflict, who are focusing strategically on a longer-term plans as well. And we know this for a fact, again, looking at the standardization processes and IP that's being generated and how they're thinking of using technologies like 6G and quantum in the future as an offensive opportunity, specifically around ways that they could operate in a multi-dimensional space. So I think there's a lot moving at the moment, but I think these are the big sort of strategic global changes we've sort of seen over the last 18 months.
Thank you very much. When I was listening to those 3 points, it brought me back to one classical academic dilemma, which as university professor I discuss with my students from time to time. Is it still really true that military drives technology or technology drives military? How this dilemma looks today, having in mind those very rapid developments of different type of technologies which are, again, integrated into different forces?
Yeah, I think that's been the ultimate. I mean, I always tell this story, if you go back to the 1950s and 60s, it was military in the space race literally drove technology. And we went through waves of that where it was ahead of the curve. To this degree now, we've sort of pivoted to the other way, where the military is starting to look at using the advancements where the consumer or commercial technology's gone. But as I said, the risk is that you over-pivot to one for the other, because in reality you need that duality, because there is so much functionality or capability the military needs which does not get designed into the commercial systems. So I think that role of the standards becomes incredibly important. I think academia plays a critical role here also for helping rapidly prototype and test a lot of this capability, which may not on day one have applicability to the enterprise sector, which would drive the bigger investments, but it would allow its utilization within the military. And I think that's where we've started to see sort of a mindset change. As I said, 18 months ago, if you saw this in the US, it was the other way around. Now I think they're coming to this realization as well, that they need to start focusing. And that's why you're starting to see, as I said, more interest in, say, open technologies, where it provides both the military and third parties the capability to adapt rapidly technologies and advance them that are maybe for a niche specific use case that in the future probably will have commercial or enterprise applicability, but it maybe doesn't have it on day one today. So for example, I mean, I'll use 6G as the example. We know for a fact other nation states from a military perspective are not waiting for 6G to be delivered on 2030, in 5 years' time. They will have capabilities available in the next few years that will be early before 6G is standardized, that they'll be able to use from a military perspective, specifically areas like terahertz radio frequencies to utilize with ultrasonic weapons. We see that already coming. So there's lots of areas where research is leading to early utilization by the military, but it's not going to move itself into the commercial sector as fast. So I think there's a duality here. We know, of working together as the only way I can sort of summarize that.
Thank you, Steve. Now I would like to ask you, Luz, you are here from NATO, and NATO has been always portrayed as a very connected alliance already, and the whole procedures, operability, interoperability, and more. So how does it look from a mobile connectivity perspective? What is the state of affairs in NATO right now?
Thank you. So, so within NATO, I'm part of NCIA, which is the NATO Communications and Informations Agency. So just to give a brief introduction on it, we are, let's say, at the forefront of tech and cyber within NATO. And we are also, and this, I think this is key, one of the things that we do is we provide unbiased information and advice to our allies, to our different NATO stakeholders, which puts us in a position where we can look at things quite holistically, and that is actually the view that we have. So within NCIA, actually, we have quite a holistic view. So we don't only talk about connectivity, we talk about how the different technologies that we're looking at today, moving forward and in a horizon, let's say, of around 2030, would interconnect and would be interdependent. And then you need to start thinking about not only connectivity in the sense of 5G, for example, but how do we provide the right cloud infrastructure? How do we look at things like cybersecurity? How do we look at things like resilience? And we take into account all of those. Now, focusing specifically on what we're doing in 5G and beyond, I think we have two dimensions that we look at. One of them is capability. So from a capability development perspective, what do? We first of all maintain quite a technology watch, like I call. And I don't know if any of you might be familiarized here, but we do even have like a quarterly newsletter that we issue on 5G, looking at everything that's happening around next-gen networks and beyond. And we look at different scenarios and different possibilities and use cases within defense of this 5G technology. We look at it specifically on the tactical operational area, which is the area where we're looking at future capability development. We do research. And the second dimension that we look at, and you've already mentioned it actually, is interoperability. So within interoperability, and specific at NCIA, we're focusing currently a lot on standardization, because we think that standardization is one of the biggest challenges we have today if we really want to become truly interoperable and we want to enable everything to come together, and 5G in this case, or and beyond, let's say, as the basis to be able to interconnect everything. So those would be the two key dimensions. One is capability development, and the other one is interoperability. Now, if we look at specific initiatives, some of the things that we're doing is, one, we conduct research, and we are actively involved in research around 5G and around 6G already. Two, we also have, and we're looking at NCIA as establishing a 5G testbed, where we can look at specific military use cases and applications that we need, and how do we implement that in a, let's say, in a military environment. We also have a multinational project that we've just recently established, which is a multinational effort to actually have 5G and look at different use cases from a more global perspective. So what is not only the applications that we could see from one nation's perspective, to put it this way, but from several of them. NATO-wide, and it was just mentioned in the speech before, there is also an initiative on the digital backbone rapid experimentation around 5G, and we are heavily involved in all these initiatives. No? So.
Thank you very much. And are you following also research done around the world? Do you following, for instance, how also those startups, not in very friendly countries or even potential adversary countries, are developing different technologies to be used in defense sector?
I think that this is, and probably it would give for a long talk, I think that one of the things that we need to look at is that when we look at a security perspective, for example, from 5G, in many times we address 5G from, okay, we need to address security and communications. There's also things when we talk about a non-commercial environment that we need to address, issues like what is the exposure of targeting that we're vulnerable to, what is the exposure that we have of being detected. And so that requires that we look at different technologies that are being developed by different companies. Within NCIA, probably around research and around having, let's say, a bird's eye view of what is happening, at the beginning of October, we presented NCIA's technology strategy. We had a first consultation event, in which precisely we presented 6 key technology pillars. One of them was next generation networks. To this consultation event, we invited, in this case, let's say, NATO scope, industry players. We also invited academia. We invited non-for-profits. We had different NATO stakeholders there. And we presented what our aim was, why we had selected these 6 key technology pillars. We had a specific panel on next generation networks, and we searched for their feedback. One of the assistants there was precisely Diana, which is the innovation body, let's say, within NATO, and they have extensive and intensive contact with different startups that are showing up in, not only on connectivity, by the way, but everywhere. So yes, we are very interconnected. That's part of our technology watch activities.
Mm-hmm. Thank you very much. Now I would like to give floor to Ingmārs. So you are from Latvian biggest mobile company, Latvijas Mobilais Telefons, and you are very actively integrating yourself into integrating mobile connectivity in armed forces. So could you please share with us what is your company's experience in being part of defense industries these days?
Thank you. Yeah, so probably we should have a little bit of a look back. So why I'm actually here, why do I sit on this stage? And this all kind of started 7 or even 8 years ago, a kind of a seminal moment when we were asked by a team of National Guards from Riga Technical University, can we lend them 20 used smartphones? So we said, why not? We can lend you 20 used smartphones. What are you going to do with those? And that was the seminal moment which opened us as a classical mass market mobile operator to the concepts of command control systems and the fantasy that every soldier these days has his own private smartphone in his pocket, which is a great communications and computational device. So, and of course, since then, many things have moved on, and many things have changed. But that was the seminal moment, because that also coincided with the time when the fantasies about 5G were showing around. And of course, we clearly realized that no one needs 5G, because no one has seen it. And so if no one has seen it, no one will actually buy it. So many operators around the planet, they still perceive 5G as just a broadband device. So, and defense was one of the earliest verticals where we actually deep dived and researched what are the industrial applications of 5G future promise, which we actually do see is happening just about now. So actually this time between the fantasies which were traveling around 2017, 2018, 2019 are just from the technical perspective, we are just about now ready to do those. So we ventured into this world, and luckily we are a very small country, which turned out to be a feature, which kind of our USP, because as we have noticed now in the bigger markets, the distance within the ecosystem between the operator and the government, between the operator and the universities and government and universities and so on, is quite long. So here it turned out to be that this public-private partnership was very fruitful. So we actually set out together with our armed forces and the ministry to build this first 5G military testbed, which is actually inbuilt within the military range here, which gives us the possibility not only to join like Nokia and Ericsson under one roof, but that this one roof is actually located within the military range, which is also a home for certain battle groups of certain different countries, with all this security, which gives us also the possibility and test and integrate all the so-called green stuff, also the military-grade technology, which also, and this all coincided with the moment, as I noticed, that actually NATO was turning its head back to civilian sector, because probably militaries around the world have noticed that civilian technologies in communication in many theaters around the world have surpassed the capabilities of classical military communications, being way more cheaper, way more adaptable and versatile. So, and all these years, so we've been part of this journey where NATO is more and more accommodating all the beautiful stuff the civilian sector has done on the 5G side. One of the reasons also being that armies are not only waging war. We should actually hope that they don't wage war, but 99% of the time armies are doing many more things like training, running huge complex industrial storage, and many more industrial processes that are much more alike to a seaport or some manufacturing company, being very, very complex. And so what we've seen so far is that thanks to this good cooperation between our government and our armed forces and us, actually, we've been able to venture very far from these 20-use smartphones into this week and previous week, probably the biggest wireless experimentation of NATO is going on here in our military testbed. So we are looking into multi-domain operations, where we see the ambition would be that the single 5G core is controlling many different networks, being different. For instance, right now there are some private networks of different vendors are located on different naval ships. They are linked also with different satellite communication media. They are also linked to the commercial mobile network on the shore. They're all managed by single brain in the single 5G core. So that would be the ambition also, as Ms. Fernandez mentioned, the ambition of standardization. Are we actually able to interlink different networks and different capabilities brought by the different member states of the NATO into one team? Last year, we also showcased the ability of one brain being here in Latvia, managing many networks, one of those being in Idaho in the United States. So actually these technologies are becoming more and more adaptable, and not only communication-wise, but we are also seeing from war in Ukraine, where we, of course, are trying to learn as much as we can, since us also being a frontline state, The Ukrainians are doing the most and utmost. Whatever is happening right now is happening there. So we also are seeing that mobile network is not only the means for communication, it's also a great sensor. So this somewhat leads us a little bit to the 6G future when we talk about sensing. So the performance of mobile network is also helping to monitor many things happening in electronic warfare as well. So I do believe that this cooperation is having, so to speak, a bright future.
So thank you, Ingmar. You are just starting those close relationships with the armed forces and contributing to security and stability of Latvia, but also transatlantic area. But I was wondering, in Latvia we very often complain that our companies are small, that probably they are not reaching the global scale and their impact can be limited. But in recent years there are more voices from companies themselves that those companies which are large ones, for them it is much more difficult to adapt to concrete needs of defense forces in their specific areas of operations. So for you, for LMT and what you are doing, the size matters or not?
Well, size always is a factor. At least I do believe. I guess we are large enough for our country, but we are small enough to be fast. This is interesting. We didn't know it before. We've learned it, so to speak, over the last years. That actually, this ability to discuss stuff quickly and agree within the ecosystem quickly. Like, for instance, if you want to do some exercise with jamming the network on larger area. In a bigger country, that would take a year to actually accept this between different authorities, being military, aviation authorities, and many more. So in a small ecosystem, this is much more achievable. And combined with the principle, I think, which is growing in fame, the principle would be get your hands dirty. I mean, not only dwell into PowerPoint, but actually as soon as possible try to do some physical stuff, try to do something in particular that actually helps you to grow a team both on the company side as well as on the army or the government side that actually has seen stuff happening, and combined with the speed within the ecosystem, that actually helps, or so to speak, that facilitates that we also, as being a small country, also are a good contributor to NATO itself, and just by being faster than big countries.
Yeah, thank you. Now it's time to turn to Evi, Lieutenant Colonel from Joint Armed Forces, headquarters of National Armed Forces. So Evi, you are the one, and your colleagues are the ones who are benefiting from innovations in mobile connectivity. How it looks from your perspective, what you have already achieved and probably what you would like to have more?
Thank you. Actually, I would like to turn back to the previous aspect of the question about a small country. I'm not a good painter, in fact, but I would like to try to illustrate the actual battlefield or the operational battlefield that we are facing here in Latvia. Even though the small country, we do have these several dimensions, and I would like to return back to the physical layers, which we have everywhere. It doesn't matter the size, but we have the land and sea. We have the airspace above all of these two domains. And then if we go further and deeper, then we have cyberspace across and inside of all of these three domains. We have electromagnetic spectrum surrounding all of these four domains. And we have space surrounding everything then. And if I made this illustration maybe not so clear, then I would like to add that in each of these domains, and by the way, NATO has recognized all 5 domains as operational domains, then each of these domains contain and have specific technology, specific platforms, specific assets that can be utilized to support defensive operations. And each of these specific assets being placed in each of these layers need this connectivity to each of the other domains. So this brings us back to the multi-domain thing, multi-layered thing, and multispectral thing. And what is the military perspective, that all of these need to be interconnected for timely and sensitive let's say, targeting, for timely decision-making, for support of all effectiveness of the defensive operations. And what from the military perspective is maybe important to emphasize that all of these technologies are actually supporting the warfighting functions that has to be achieved and to get this effectiveness. So if we go back to these functions, that these are being the command and control already mentioned, and information as such, and information as we know who owns the information first, that one controls the battlefield. So speed for the information gaining is very important. And all of these initiatives that are being developed across the industry is really the ones that are being adopted to in the military as well. So I would say that would be the ones illustrating my perspective there.
If I would like to continue a little bit on the same note which you ended up. So there are a lot of demands having in main those 5 domains which are relevant for the defense sector. What, from Latvia's perspective, looking at defense thinking, defensibility of the country, being from the perspective of being part of NATO military structure, from technological perspective, what would be now demand number 1? What you would name as a demand number 1?
What I would like to emphasize the multinationality here in Latvia. We have different partners and coalition forces here in Latvia deployed, and the interconnectivity, the interoperability, and connectivity as such between those different operators, different forces here is vital for communications, for data exchange, for informations that brings up together the decisions. And these are the requirements that currently are not really solved. And we know that there are sensitive informations for each of those nations, and we have our own secure things and informations that we maybe are not able or not willing to share. And then all of these requirements have to fulfill these needs so that the information exchange can be achieved. No matter what is the qualification, what is the security. So the forces have to be interoperable. And yeah, I would say that this is the biggest challenge at this time, to find the best solutions in each of the, let's say, levels. We have the tactical level, which are the closest forces operating together. We have operational levels, conducting and doing the planning and synchronizing all the activities across all the domains. And we have also the strategic level that also require that information at the speed of relevance to take the decisions, to have the right consultation timings and everything.
Mm-hmm. Thank you. We have some minutes also left for Q&A session. So Valdis could assist us with microphone. If somebody would like to ask question to our panelists on mobile connectivity in defense sector, you could raise your hand, and now it's a moment to ask questions. Oh, there is Valdis there. On
sure.
the, yeah.
Please announce yourself, and then I'll come back. Yeah, there you go.
Thank you very much for the interesting discussion. I'm Uwe Herzog. I'm Euroscom. We are a small company in Germany. And I have a question about how safe it could be to use 5G, 6G technologies for military application. And what I have in mind is that these type of networks, they are mainly designed for use by residential customers, by companies, etc. I understand these are very interesting also for use in military applications because of their fancy opportunities that they offer. But at the same time, when they are deployed for military use, do we not also buy in all the vulnerabilities that these networks have? For instance, I heard when you want to interconnect between ships and use it via satellite communication. We know how easy it is nowadays to shoot a satellite. Wouldn't we buy in severe risks by too easily deploy this technology for military use? How do you see that?
I'd be happy to take this one.
Yeah.
This is particularly the reason why this is being done. So I'm using as many networks as possible. Because right now, as you've seen in war in Ukraine, walking around with a field radio turned on is probably your death sentence. Because no one cares for what you are saying over the field radio. You would be bombed by a mortar if you would stand for too long, too close to a battlefield with your field radio, because your field radio is very, very much visible. So its radio footprint is very much visible. So no one cares. No one cares to hack you. They just know if you walk around with your, I don't know, let's say a Harris radio, you will probably just be bombed. So this is one aspect, so it doesn't matter. So the other, what actually matters is how many networks can you actually use simultaneously? Can you integrate your private mobile network? Can you integrate your commercial network? Can you integrate satellite communications? Can you integrate field radios? We've showcased that you can actually, we showcased a solution where you can actually call from your iPhone to a field radio. So these two networks being interconnected. So the key here is interoperability and simultaneous usages of as many networks as possible in a secure way. And I would somewhat also would like to oppose. I think the 5G network is not meant for humans. It's not needed for humans. Everything that could be addressed in a plain old broadband could be done by 4G networks. We don't need, I mean, the 5G is nice, it's a little bit more frequencies, a little bit better frequency efficiency, but 5G is not that important for broadband. 5G is mainly industrial solution for machines and robots, so, and the security level of 5G is again one step up from the previous generations as well. And last but not the least, particularly if you're doing a warfare in an urban area, actually one of the benefits of using, even beyond all this what I mentioned before, one of the benefits of using mobile technology is that you blend into the civilian background of the radio. So if you would walk around the city with your field radio, you would be even more vulnerable. So there are many aspects to this, but yes, I do believe that first and utmost, it's the multi-domain operations using as many networks as possible and being kind of a mesh of different technologies.
So are you saying that lowers the traceability of the user?
I would say that having many networks opens up more options, and you are much harder to. I mean, in the classical sense, if you have a centralized network, if you take out some of the elements, the network dies. So if you have many networks, you are much more adaptable to whatever happens.
Maybe I can just add a little bit on.
Please.
Yeah, just to extend on that. I mean, well, again, a learning that we've been watching at the moment is that with the earlier generation, say of 4G and the first wave of 5G, the non-standalone. There was a huge issue about being able to rapidly identify, a user from their identification and their location. Standalone 5G actually brings new capabilities in that actually prevent that there. So there are enhancements in addition to, I absolutely agree, it is about multi-networks, not depending on one, but there's a lot of additional capabilities that the military is now looking at to create that security. So combining things like standalone with private networks rather than being dependent on the public network. Although there is an interest in using what they call operate through, where you could use a public network. Secure slices are being looked at, how you integrate tighter with satellites to use secure bands that are available to the military today, in addition to unsecure. So again, it's this whole combination, but I think it is interesting that we're starting to see more and more capabilities, which were initially, by the way, designed from an industrial perspective to provide security in mission-critical industries, but are now very applicable also now to the military and to create new levels of security there. So I think that's a positive step forward, and that's why you're starting to see more interest in adopting it. So to your ship point of view, in many cases you're seeing a lot of trials today where they're creating a private network on board the ship itself, or to create interconnected battle groups, where it's a private 5G standalone network integrated with satellite comms, integrated with HAPS, to provide sort of that their ubiquitous multi-dimensional network from land, sea, air, and I think that's potentially where the future is going.
Yeah, Luz would like also to respond, sorry.
Yeah, just to add into what they were saying, I think we also need to look at two dimensions, in my view. One of them is we know that through, let's say, 5G and beyond, we can now cover, let's say, maybe 70% of applications. And like the person who was asking was saying, we do have, and we look at most applications coming from the industrial. We still have to look at the military, let's say, classic or older systems to have a fallback on that. So we also look at this type of technology from an augmentation perspective, meaning that interconnectivity can enable, let's say, the classic systems to also continue acting. That would be one. The other one, and I think this is key, is that it's key to have the proper research and the proper experimentation basis when we look at how we deploy specific technologies in military use cases. Many times we see that there might be a temptation, let's say, to take off-the-shelf solutions and go ahead and experiment in a military context. And then you might see that the band is not the right one that is being used, or that we're not looking at the right conditions in which we're testing. That this could happen, for example, in maritime, right? So I think there's two things. One is we need to look at it from the sense of augmentation and taking into account a word that has been named a lot here, which is resilience, which is we cannot only look at one, and I fully agree with the multi-network position. But the other one is it's key to have a proper basis before jumping into experimentation and really having a scientific method when we look at how we apply these technologies into the military specific use cases.
Thank you. There was one more question. Sorry for letting you wait for so long.
That's okay, thank you. Dean Bubley from Disruptive Analysis, and I also help run the 6G Reset Initiative. Within 5G, there are many sort of elements and different releases, and then with each release of 5G, there's lots of sort of optional add-ons and features. When we're talking about defense, do you look at the whole entire span of 5G, so the things that are for ultra-low latency or for XR or for non-terrestrial networks and drones, or do you just use mostly the radio and then essentially create your own features on top of that?
Yeah, thank you.
I could
Please.
start out with one of the first experimentations was actually particularly about the XR. One of the use cases was experimenting, can you do the training of different teams from different geographical locations within one virtual space? That was one of the earliest, actually, use cases, because, as I said, armies are not only waging war, they are doing something else most of the time, like training. So training is one of the key topics for all the military. So actually, adoption of augmented reality and XR is one of the topics. Substitute to GPS is probably one of the other ones. So there is this fantasy that, which we also do research, that you would use a signal from massive MIMO antenna in a passive mode, so that will give you a possibility to calculate your whereabouts based on the signal from the antenna. So that would be, in some specific scenarios, that would be a substitute to GPS, which is probably we can easily forget about GPS as a technology. This will not be used ever, probably in the future, so we need to look for alternatives to GPS. So this would be another one of examples. There are actually many more, but probably somebody else can comment.
Eve?
Yeah, in addition to what Ingmar's already mentioned about the integration of XR and substitution of GPS, we also have the initiatives integrating also the normal tactical communications into the 5G. So interoperability between these is also an importance to have the battlefield extended also outside the maybe urban areas and to be able to operate or to extend this 5G bubble more. So, but yeah, as mentioned, we do the training as our basis, and then all the initiatives that can supplement to this to allow us to, let's say, utilize our PACE plan, which is the primary alternative contingency and emergency plan for the networks. So all of these additional add-ons and options that can be utilized is always an option also for us to choose and to be able to integrate them into our training and to be able to adapt to these options and technologies. Thank you.
Yeah. Stephen, please.
I mean, just to add to that, Dean, I mean, you've just heard, I think what we see from the testing and the testing demand of where they're interested in looking at, it is multidimensional, because what's needed for, say, peacetime, as was just highlighted, and on a smart base probably brings in more 5G capability than, say, if you're out on a forward operating environment where radio probably becomes actually more important. So, for example, we're seeing a lot of interest and demand in using the sidelink technology in 5G to create mesh networks for allowing direct device radio comms. Now that's got applicability back on the base, but it's not likely. I mean, there's more use cases like using augmented or virtual reality. You're seeing more use cases where the 5G core is involved there as well, in terms of creating even just independent slices on the base for specific levels of security and giving access to troops while they're there, because they're using it as well for own personal use. So you see a lot of those types of use cases. I would say the one challenge that we have seen for many years, and this isn't just for the defense sector, is that in the multiple releases of 5G, we're coming up to sort of release 18 now, there's a huge menu of features that have been defined. And in reality, when you look at even just commercial operators, probably only 20 to 25% of those are getting adopted. So there's a lot of capability that has been defined but hasn't been commercialized. And that doesn't mean there's good capability in there, but it does become a little bit of a menu of which ones are going to be the most relevant for which use cases. And I don't think yet, from what we see, there's a lot of experimentation and learning. And I think that you highlighted one of the best points there. There's a lot of research and testing and trials that need to be done. And a lot of countries are now starting to look at concepts of how you can do this, both physical, which is difficult for big countries, as was mentioned, because you can't necessarily close down airspace that easy to do large, say, jamming events. But could you do that digitally? We're using like digital twins or virtual environments to create wargaming, and we're seeing more and more demand or interest around that as well, to understand what type of resilience and mitigation mechanisms you could actually build or put in place.
Mm-hmm. Thank you.
Any other questions, please? Yeah, just put up your hand. So
here.
Yeah.
We could take the last question because the time is running out.
Thank you. Ingrid, I represent Latvian Council of Science, and I work a lot with international projects in security field covering dual usage, civil and military application. Thank you very much for insightful information. And considering very crucial area you have mentioned, that especially in the military field, in the defense field, it is a key technology point to ensure interoperability, openness, and scalability. And maybe a very practical question from my side. We know we already have an existing domain with long-time working technologies, yes, and we have our 5G and beyond technologies. So from technological perspective, I know as an engineer myself, former engineer, that one of the biggest challenges it is to ensure this integration and compatibility. It is yet novel and stable. So from your point of view, what will be the greatest challenge, in integrating existing technologies, with the new ones, with the approaches we are going further, For example, you have mentioned also that one of the challenges could be the broadband, the frequency band compatibility. We know that our goal is to ensure that everything works fine, it's functional, open enough, yet closed enough, if we refer to the military. So could you mention some technological challenges and maybe your approach, how to solve them? Thank you.
Thank you very much. Who would like to answer this question?
Just a quick one.
Okay.
Quick one. Probably I don't see that many, well, there are many interesting technological challenges, but probably most important, if you would see, well, if you take a look from a rollout perspective, is probably not technological, it's administrative challenge. Since from my commercial perspective, now I've learned a little bit more about the lifestyle of defense industry. And so the procurement cycle is really long, and they are not so huge, they're quite tiny. So, and it happens slow. So there are many, many countries, and this procurement cycle probably doesn't coincide so well. So it's not so hard to solve interoperability right now. As I said, we can make a call from iPhone to a field radio. That's doable already. There is a GEAR for that. But for so many countries and so long procurement cycles and procurement strategies of different countries, I think that would be if you would like to roll it out all over the place in many countries, that would be, to my understanding, probably the biggest challenge here.
Maybe I can add a little bit to that. So I always say that when we talk about interoperability, we talk about it in two senses. We can talk about interoperability between systems, and let's say from a NATO perspective, we would talk about interoperability across the aliens. When you talk about interoperability across systems, you start looking at technological challenges like, okay, how do we interconnect, let's say, legacy systems with newer technologies? How do we look at forward-looking technologies and, being able to integrate, for example, different test beds that we might have on different technologies to look for use cases that use all of them. That is one of the key challenges within NCIA, for example, when we look at the 6 key technology pillars that we're looking at. So let's say I could name space, cybersecurity, cyberspace, cloud, data exploitation would be another one, quantum would be another one. We always look at that interoperability among systems and the interdependency that technologies carry to enable one another, actually. But when you talk about interoperability across the aliens, you also have to look at the people and process perspective. You have to look at things like maturity. You have to look at things like collaboration, which was also mentioned here. Have to look at things like what are the consequences, let's say, or the challenges, to put it this way, of isolated research versus having a more collaborative research and approach. And you need to tackle each one of them, right? So I would see it, like I said at the beginning, in a more holistic view when we talk about interoperability, taking into account the whole dimension, and also the different layers and the different domains that we're talking about when we talk about multi-domain. So.
Thank you very much, Luz. I think that the good panel is a panel which doesn't answer all questions. But at least I'm quite sure that this panel contributed to more questions, which means that there will be innovations, there will be adaptations and adoptions. So please join me in a round of applause thanking our panelists. Thank you.
And, thank you, moderator, Žaneta Ozoliņa. Thank you.